In this video, we will talk about the Pythagorean identities. So there are three Pythagorean identities. The first is sine squared theta plus cosine squared theta is equal to 1. The second is the tangent squared theta plus 1 is equal to secant squared theta. And the third is cotangent squared theta plus 1 is equal to cosecant squared theta. So let's work through a few problems and see how we can use these identities. So let's say we are told the cosine of theta is equal to 12/13. And let's say we want to find the sine of theta. How can we do that? Well, it looks like since we're given the cosine of theta and we want to find the sine of theta, the first Pythagorean identity is what we will use since it involves the sine and the cosine. So let's go ahead and write that identity and fill in what we know. So we have sine squared theta plus cosine squared theta. So we're told that cosine of theta is 12/13. So we just have 12/13 squared is equal to 1. So if we simplify, we can write sine squared theta plus 12/13 squared. So we just need to square the numerator. So 12 times 12, that's 144. And we can square the denominator. 13 times 13, that's 169. And all of that is equal to 1. So it helps if we can write 1 as a fraction with the same denominator as 169. So if we write that, that would be sine squared of theta plus 144 over 169 is equal to, and 1 as a fraction with the denominator of 169 would just be 169 over 169, because that's still equal to 1. So now to solve for sine of theta, we just need to subtract this 144 over 169 from each side. So if we do that, let's write that. Minus 169 minus 144 over 169. We'll be left with sine squared theta is equal to, so since these two fractions have the same denominator, we can just subtract the numerators. So 169 minus 144, that's 25. So we're left with 25 over 169. Now to solve for sine of theta, we just need to take the square root of each side. So that will leave us with sine of theta is equal to the square root of the numerator, 25, that's just 5. And the square root of 169 is 13. So our final answer is 5/13. Given that cosine of theta is 12/13, we found that sine of theta is equal to 5/13. All right, let's try another one. Let's say we're told that the cosine of theta is equal to 4/5 and we want to find the tangent of theta. Well, if we want to find the tangent, it looks like we'll be using the second Pythagorean identity since this includes tangent. So let's go ahead and write that identity and fill in what we know. So we've got tangent squared of theta plus 1 is equal to the secant squared of theta. So if you'll recall, the secant is just 1 over the cosine, or in other words, it's the reciprocal of the cosine. So the reciprocal is just, we switch the numerator and the denominator. So we can write the secant as 5/4, and that will be squared. So if we go ahead and square that, let's write tangent squared of theta plus, we'll have plus 1, and we'll equals 5 squared is 25, 4 squared is 16. So what we can do, remember the trick that we used in the last example, is rewrite this 1 as a fraction with the same denominator as this fraction. So this has a denominator of 16, so we can rewrite 1 as 16 over 16 to make it a little easier to work with. Now to solve for tangent, we're just going to subtract 16 over 16 from each side. So that leaves us with tangent squared of theta is equal to 25 minus 16, that's 9 over 16. So let's rewrite that over here. Tangent squared theta is equal to 9 over 16. And to solve for the tangent, we'll just take the square root of each side. So we're left with tangent theta is equal to, the square root of 9 is 3, and the square root of 16 is 4. So our final answer is 3/4. Tangent of theta is equal to 3/4. All right, let's try one more example. Let's say we're told the sine of theta is equal to the square root of 2 over 10, and we want to find the tangent of theta. Well, the sine of theta is equal to 1 over the cosecant, which we have right here in this last Pythagorean identity, and the tangent is 1 over the cotangent. So it looks like we'll be using this last Pythagorean identity here to solve this problem. So let's write what we know. We have the cotangent squared of theta plus 1 is equal to the cosecant squared. So we said the cosecant is just 1 over the sine of theta. So the way that we can write that is just the reciprocal, or in other words, we'll switch the numerator and the denominator. So we can write that as 10 over the square root of 2, and remember we have it squared. So we're left with cotangent squared of theta plus 1 is equal to 10 squared, that's 100, and the square root of 2 squared is just 2. So we have 100 over 2, which is 50. So let's rewrite this as the cotangent squared of theta plus 1 is equal to 50. So solving for cotangent, we can just subtract a 1 from each side, and we're left with the cotangent squared of theta is equal to 49. So if we want to figure out what is cotangent, we can just say the square root of each side. So we're left with cotangent of theta is equal to, the square root of 49 is 7. But remember, we want to find tangent, and we know that tangent of theta is equal to 1 over cotangent of theta. So we just found the cotangent of theta is equal to 7. So that means the tangent of theta is just 1 over 7. And that is our final answer.